Sir Ramarao, distinguished members of the faculty, invitees, my dear students. Today, I really feel honored to address this forum, and particularly you all have heard what Professor Ramarao said, that for 35 years, in an unbroken tradition, this science festival has been going on. It may look ordinary to organize lectures, but to do this in an extraordinary way, in unbroken fashion, that is greatness. Greatness is nothing else than doing ordinary things in extraordinary way. The topic I have chosen today is something which is close to my heart because I spent many years in Indian Space Research Organization, and one of the missions I worked for is to develop industries in India which can take up projects and develop products and develop services based on the space systems. So to that extent, many of the ideas that I will be giving to you is based on my experience. Space has been, of course, an important dimension of human endeavors over the past few decades. The space activities themselves started only in 1957 when the first artificial satellite, Sputnik, is put into orbit by Russians. Since then, of course, space has advanced through discoveries, through several extraordinary achievements of engineering, has progressed well, and today it is part of our lives. And its role is immense if we look at its role in the global commerce as well as national security. Since 1957, space activities captivated the minds of people. Men have landed on the moon. Robots have explored areas of Mars. In fact, a probe has returned the material from a comet. And the spacecraft have journeyed to the edge of the interplanetary space. Overall, since 1957, 6,000 satellites have been launched by various countries. More than 300 human beings were in space. Today, 10 countries, including India, is capable of launching satellites into space. It's a very, very intricate, involved technology. Very few nations in the world have this technology, and this technology is not available for buying. And 60 nations, of course, they own the satellites, they have made the satellites, and they use the satellites. In terms of using the satellites, there are more countries, more than 100 countries which use the satellites. But out of the 6,000 satellites which were launched, most of them were for the military purpose. And in fact, out of the 4,900 satellites which were launched for military purpose, 4,800 were launched by these two then superpowers, the USA and then Soviet Union. But today, of course, that era is over. About 200 satellites are used for military purpose. To show you how the dominance of competition, military superiority competition was there, this picture is very spectacular. What you see as a white band is the progression of time. Ever since the start of the space activities in 1957, the ordinate, the y-axis, it is basically the number of satellites launched. All the orange color satellites, they belong to the Russians, the blue ones are the American satellites. All the satellites below this white band is essentially military satellites, whereas the civilian satellites are above this. You can see how dominant was the military application, and of course these are the satellites used for the meteorological weather observation purposes. Since very beginning of space activity, there was interest of military in knowing the weather. Similarly, even the scientific and research satellites were not spared by the race for superiority. And here you can see these were all the military satellites. And again, this is Russian, this is American, and subsequently, other countries in other colors you can see. Japan, India, China, and so on. These are the satellites which were used for the space probes, spatial probes, scientific satellites. One good spin-off of this race for superiority was that it gave birth to the concept of space commerce itself. How? The dollars and programs came from the government for the military purposes, and the industries used their intellectual abilities, and particularly aerospace industries, and they created new technologies and facilities mainly for the military programs. And these programs were used with adaptation for many civilian applications. That is how they made great cost advantage, got cost advantage, and sold those products and services. Particularly initially, all the communication services were given by communication satellites, and all the technologies for the communication satellites without reinvestment came from the technologies developed for the military purpose. And of course, subsequently, they started serving not only the domestic markets but also the international markets. And today, of course, many companies, they service domestic and international markets, and there is competition. There is a competition, and there is also competition not only from other players but also alternate technologies. So the space has to confront, space technologies have to confront competition from other technologies and so on. The game changer is the end of the Cold War. When the Cold War between the then Soviet Union and USA ended, then began a change in the whole dimension. The commercial programs started, in the driving seat, because the governments did not want to spend too much money on military activities. There was no incentive. The budgets for military activities, space activities came down, and the commercial activities taken, the precedence. And of course, initially the industries leveraged on the programs, military programs, to create infrastructure. But after Cold War, it is the capacity has already been there, that mature capacity was there. And while the growth was key in the pre-Cold War era, subsequently it is the question of consolidation, how the industries can work together to make a good profit, increase their efficiency was the key word. So the competition also, which used to be between a few powers, has diversified. There was a bigger competition. Today, the governments spend something like $87 billion totally globally. And you can see from this graph picture, this is mostly it is spent by the United States. 75% of the budget is spent by the United States. This is European Space Agency. This is China. This is India. India is blue, indigo color. And then the other European countries, Japan, and then France, Germany, and so on. So this is all other countries together. This is how the total expenditure, $87 billion, is distributed among various countries. But what makes the space business tick? No more militaries are spending so much expenditure, and how the space industry, space business is going to sustain. Well, that is where the space technology's advantages are to be seen. Space is insensitive to distance. That is, once you have a spacecraft at a height of, say, 36,000 kilometers, it can see almost 40% of the Earth's surface. So, 2 points which are as far apart as even 7,000 kilometers can talk through the satellite. The communications could be there. So the coverage instantly you get for large areas, for regions, for countries, or even groups of countries. You can get coverage through space. That is how, you can very quickly grow, you can very quickly cover the services. In India, it was taking long time to spread the television transmissions to different places. Each place, you have to set up the terrestrial facilities. But once the satellite came, the coverage increased very rapidly. That is how the space can give advantage for coverage. Similarly, there are other important characteristics like resilience to disasters. Space can easily interface with other technologies, and that is what we call it as convergence. Because it is a multidisciplinary, different fields of engineering and science have to mingle together to make space systems. There is a possibility of many innovations. That is how it is possible to take advantage of space technology and still make a good business out of that. What is the structure of space market? Essentially, in the space market, you have the infrastructure, that is the space systems, the satellites, which will provide the basic infrastructure for providing service. And to put the satellites, you need launch vehicles, the rockets, which take them into space. And of course, when the satellites are in their space, you need some equipment on the ground to be able to communicate with these satellites. All this come under the infrastructure, whereas using this infrastructure, you can develop many services. Services like direct-to-home television, which you are very familiar, the imaging from space, you are able to take pictures from space and cover large areas, and you can have a global coverage. You can take pictures over America and download in India and sell these pictures in third country. All this is possible using space. Now, space also provides, like any high technology, a diverging value chain. You put $1 into, space activity, it can create a business of $6 or $7. That is how it expands. You can see the example here. In fact, I have taken the global investments into satellite and launch vehicle. If it is 1x, the ground segment further, it creates a business of 3.3x, and the services offered through the satellite creates a 6x. So 6 times the value of investment is that much business is created out of space activities. This is one interesting part of the value chain of space. And in fact, this value chain doesn't stop there. In fact, it gets integrated into global telecom industry, which is a $4 trillion value industry. Almost you can say that 3 times the total income of India every year. That is the value of that telecom industry, which includes all IT services and so on. Over the period, of course, there is a growth trend. Because of this characteristic, the business is steadily growing till now. So we have taken a 10-year profile and seen how the revenues are growing. As you can see, in 2010, the revenues were something like $170 billion. And there are 4 segments, of course, it is divided into. The upper ocean blue color, which shows 60% value of the total histogram, that is the services part. Services is the major part of the value created by space activities. And the bottom one is the ground equipment, like the terminals used by the users. That is 31%. The actual value of satellites and the launch vehicles, you can see, 6 and 1, maybe 7% or something like that. So 7% value investment in space activity is creating a value of 91% additional activities. In 2010, for that particular year, this is further shown specifically, the satellite manufacturing $10 billion, whereas the launch industry is $4 billion. Rest is ground equipment and services is more than $100 billion. Today, nearly 1,000 satellites, although we said in the beginning 6,000 satellites were launched from the very beginning of the time for first satellite, only 1,000 satellites, about 1,000 satellites now operate. And of course, these satellites are in different types of orbits. That is what is shown in the here. This is geostationary orbit at a height of 36,000 kilometers used for communications. This orbit is in the plane of equator, and these are the low Earth orbit. It is at a height of about 800 kilometers or 1,000 kilometers. It is mainly the satellites which are put for taking pictures of Earth or for other purposes like the scientific missions and so on. Here, the breakup of various types of satellites are given. Science satellites, for example, about 5%. Remote sensing satellites is about, this is picture taking satellites, about 9%. Then navigation satellites is about 75%. In your mobiles, you get the GPS signal. It will tell you exactly where you are. It will tell you that you are in the National College. Okay, that is possible through this set of satellites, and we will learn about it a little later. Now, all these satellites, of course, are used, as we have seen, they have purpose, and some of them are used for the business purpose. One important business we have seen is the communications satellites. These communication satellites are parked in the geostationary orbit. And of course, geostationary arc is a limited arc, 360 degrees. And each satellite, you should have a separation of at least 1 degree. So there are too many contenders for this orbit, so you need parking management. So the international organization called International Telecommunications Union, they allot the parking places, and also they will allot frequencies, and these frequencies are to be coordinated with the neighbors. So it is an elaborate process. So tomorrow, if some business company, even if they have several 1,000 crores and they want to have a satellite, they cannot have, because they need, like on ground we need the land to make a real estate. You have to have this frequency and orbit location resources. So it needs a very long-term planning and long-term play when you want to get into a space business like that of making a satellite and putting it into the orbit. Now, technologies are developed to put the satellites at the same location. Multiple satellites are put in the same location. So that technology even India uses. India has at one location 4 satellites, 5 satellites, and my friends say it is possible to have even 7 satellites at one location with diversity of frequencies, diversity of polarization, and so on. These satellites are used for this service. As you can see, the revenue, almost all services revenue are coming from communication satellites. $100 billion is the revenue. Out of that, the television and the DTH alone gives 80%. 80% of the revenue comes from direct-to-home television. Now in the telecommunication satellites, what is the kind of potential for future? In India, we have about 40, now I think 44 million DTH homes. So it is possible to increase. You know the earnings of this industry alone is something like 32,000 crores. So in the whole world we have about 10% of this business, in service business. With a few satellites, it is possible to create this kind of business. And of course, if you take the world as a whole, total television homes are 1.4 billion, but DTH is only 150 million. So there is a scope for expanding this. Of course, you have to find the frequency and other resources, technologies are to be developed. The recent development is the high definition channels, and already most of these channels today, much of the growth is happening in the United States. Maybe in a few years, in India, you find very rapid growth of high definition television channels. Today, we have paucity for the bandwidth from space. We don't have capacity in space, enough capacity to meet the demands. So when this is developed, of course, in India also you will find more high definition television channels. These are the ways in which, business constantly innovates to make more and more money. Whatever money you have, they want to collect from you. So they will come up with innovations. Of course, there will be reduction in cost, but still, they will come up with new novel ideas. This competition is very high here. 113 satellite operators, they provide this capacity. So there is if we have to be in this business, we have to compete, because some of them are very powerful competitors. How did they become powerful? Because in the initial stages, the government of US, they created an international organization, privatized that. All the slots, all the frequency resources, it has transferred to the private sector. So these companies have become dominant. Just 4 companies, mind you, in the world, they have for the fixed satellite communication something like 75% of the market share. It is very hard to compete against them and get into them. So what is the solution for, operators like Indian operators? India wants to do it. India wants to put some satellites into space and do business worldwide. We have to compete with these giants. The only way is we have to evolve some packages for cooperation with them, and then, we have to increase our share. So it is a very complex thing, very long-term strategy is needed to tackle this type of market. The other segment is, of course, imaging. You are all familiar from the photographs or pictures taken from space. I will say it is not merely pictures. You can do a lot of measurements from space. You can measure the temperatures in the atmosphere. You can measure the water vapor content. You can measure the particle, the pollution. In fact, this is being done. The particles on the surface of Earth is monitored from satellites. So like this, you can have a large number of applications as shown here, the atmosphere, land, ocean. Ocean, you can predict fisheries for the next 1 week, which are the locations where fish schools are abundantly available. This information can be derived from space data. So all this, you can also use it for business purpose. So in this business also, we have many companies who have put a lot of investment, and thanks to the US policy, US said, in 1990s, they have opened up. They said that the companies can invest and have satellites which can make very fine pictures. Today, 1 meter pictures, the navigation you can get from Google Earth or whatever it is. All this is, even India now, I will show you a picture. This is a picture taken by India. This is a stadium. You see, this picture is taken from the height of 700 kilometers. You can't believe it. And in India, we are making this optics. In India, we are making these cameras and putting into space and make these pictures. Not only we can take pictures over Indian region, since space is free for all, we can take pictures of any part of the world and sell these pictures. That is exactly, what we try to do. And the market for this is, of course, today, as of today, it is about $1 billion. Over the next 10 years, of course, a lot of countries are coming into, fray and making the satellites. So there are 260 satellites expected over the next 10 years with something like $27 billion investment. So if we are into this field and make a mark, we have to really have a very good strategy. And of course, we have certain advantages in India and we can go forward in this thing. The other is a satellite positioning service. Satellite positioning service, there is a constellation of satellites which give you if you have a chip in a receiver can be a mobile or any other device, you will be able to determine your position. Simultaneously 6 or 7 satellites send signals and it is resolved, processed, and you know where your position is. There are plus points and minus points. Everybody can be tracked today, and if this information is gathered and processed, it can be misused also. So security is also important in this, but this ability is used for many applications. The simple application is navigation. You are in a car, the car will tell you say that I have to reach Jayanagar 4th block bus station. So it will tell you take this road, it will show the map and it will virtually take you there as if somebody is leading by hand. So such services are possible. You can also get to such mapping service or other service which is the nearest hospital to this place. And what is its address? What are the directions? You can ask the mobile and get such help. So this type of value-added services are possible. Just the chips devices for positioning in the world today is a huge industry. It is something like $60 billion industry. So this service is also done by the satellites. There are 3 constellations which are doing. One US constellation which provides free signals. Signals are given free, but rest are all costed. So when you buy a receiver, of course, you have to pay for the receiver. The launch services is the other area. For taking the satellites into space. Of course, India is one of the spacefaring country, and our PSLV has done many such services for at least 25 payloads have been put into orbit for different countries. But this is a very controlled market. Even to get into the market, you need cooperation from other countries. They will not export you even a small part if you are going and commercially launching for another country without having an agreement with the supplier of a component. You forget about the systems. Even a small component getting into a rocket, if you have to launch a satellite from third country, you need a cooperation. So US was against India providing this service to other countries. But we stood the pressure and said that we will launch, we have the capability to launch. If America doesn't give components, we will develop components and launch. That is how we entered into the market. And today all the launches we have done has been successful. Of course, we have to create now a method by which we can produce the number of vehicles and we can launch it into space. China is doing very well today, and it is also getting orders. So the other last area is space tourism. This interest has recently developed after the US, put a competition for, private investors. You can develop your own ideas, design, launch systems for the suborbital flights or orbital flights. There were rich people who wanted to have thrill, who were prepared to pay $2 million or $3 million just to go up to 100 kilometers. from Earth's surface and come back, because they are the unique set of people. Or the Russians have announced, you pay $2 million, we will take in Soyuz vehicle, we will take you up to the International Space Station and bring you back. This type of activities have resulted in many companies, at least a dozen companies in the United States, now they are making systems to take space tourists. In fact, in India also we should study and make one very nice launch pad there. Space tourists can come to India and see India and also go to space and come back. This is a potential business for future, of course. But if we have to do this business, of course, there are many challenges. Each market, each country, the policies are different. The Americans, the satellites produce 1 meter data, but they cannot come and sell in Indian market because Indian government does not allow the Indian citizens to buy 1 meter data or better than 1 meter data. Now they have relaxed up to 1 meter. There is great amount of risk involved in the space activities like launch activity. The industries, if they have to invest and have a company to produce rockets and do business, they have to have a mechanism, support of the government to reduce their risk. Because today, if they go and hit any other object belonging to another country, they have to pay a very heavy compensation, and the government is responsible to pay for that. So the government has to create laws, has to create systems by which they can protect the interests of the third parties, create insurance systems and so on. And the US government, up to $100 million, the company has to bear through insurance. Beyond $100 million, whatever may be the damage claim, US government will pay for its company. Similarly, in case of France, 40 million euros, the company has to pay, beyond which, we used to, when we launched up to $100 million, we used to take insurance, and beyond $100 million, of course, we were hoping that Indian government will support. There are also, of course, risks due to terrestrial alternatives. The space has a limited capacity, so whereas the fibers, alternate technology like fiber can give very large bandwidths, speeds, and so on. So space systems with large investments we put up with the hope that for the next 15 years they give service, but there could be risks down the lane. There is always security concerns. The government may put restrictions on business. So these are the kind of risks one has to face. And there are also other risks. When we send spacecraft into space, we have no opportunity to repair. The space environment is hostile. So the systems we have to design and develop in such a way that this failure, the possibilities are reduced to the bare minimum. Testing is very, very stringent in those cases. And in the space over a period, there is this space debris. The junk has increased. You can see this is a NASA tracks through, almost through 300 stations all over the world, and they provide this information as to, they track every object which is of the size of 10 centimeters. And there are 16,000 objects. This has been growing. One jump you see here, this is, the Chinese test in 1997. They have blown up through one of their satellites using another satellite, anti-satellite test we call it. And that has created so much of debris. And this debris, even if you don't do anything, they keep growing because the random process makes these collisions and debris particles increase. These are big debris. Even a small debris, which is millions, if less than 1 centimeter debris, if you see in space, it is millions of them. These are the debris. You can see that India has a relatively clean record. Of course, we have less number of launches. We have not produced much debris. It is all created much by the then Soviet Union and the USA, who initially they used to explode rocket stages, the spent stages. You can see this is the kind of environment. Of course, this is not to be scaled, but this is the kind of situation or risk one takes when one sends a commercial spacecraft. Always we are worried what will happen to the spacecraft. Many times I got calls during the night, complaints from the customers saying that, there are outages and so on. This is the kind of situation in the geostationary orbit. But how do we manage this kind of risks in the business? The launch vehicle always has some chance of failure, but if failure happens, it will be loss of 300 million, 200 million. The only way to counter this, manage this risk is to take insurance. So the premium for a launch is something like 14%. 14% of the value of the satellite and the launch vehicle, what you are spending. If you are spending 100 crores for a satellite launch, you have to spend another 14 crores for insurance. If there is a failure, they will reimburse the full thing. Otherwise, you lose everything. So this is the way we manage the risk. There is also third-party liability. See, it can go and hit another satellite. Then you can have a very heavy claim. So we take insurance. Of course, the probability is low, so the insurance premium is not much. It is reasonable. It is less than $1 million. And of course, any intellectual property created in space, it is outside the territory of a country, so the laws don't apply. So many parties, which if they are working together, they have to have protracted negotiations to a priori agree on what will be the kind of way in which, if there are some inventions, how they share and how it will be dealt with. These are to be discussed. And you have to face embargoes. You start the program, but in between, another country put an embargo for sending, supplying a component. Your program is stuck because there are not many suppliers in case of some components. And this is a risk you have to take. So from the very beginning, you should have plans for, if this happens, what do I do? So this scenario you have to present and convince your customer that you are not leaving him lurch because of the embargoes. There are many such risks as I have listed here, including some people living in between, but we need a very systematic type of assessment on this risk. That is what we do when we have to do space business. On one side, we see what is the frequency of occurring, what is the probability of occurring. That is the y-axis. The x-axis is what's the impact. If this event happens, what is the impact? So these two things, we map it, and especially for high frequency, high impact events, our control regime is very, very strict, and our analysis, and we spend money to avoid such risks, or if that event happens, how to overcome. We prepare from the very beginning. That is very important. Of course, there are also other legal considerations. As I said, anybody, any country have access to space. Space does not belong to any country. No country can have territorial jurisdiction in space. But they are free to go into space and conduct their activities without interfering with the other players, other countries. And in case they cause damage, in space they cause damage. They will be liable for damage, absolutely, but not absolutely, based on the fault, whose fault it is. But it is extremely tricky to determine whose fault. Two spacecraft, they come and hit each other. Whose fault it is not easy to determine. So we have to very carefully monitor, and as soon as these two spacecraft is just 1 kilometer or half a kilometer away in case of low Earth orbit, 1 kilometer away in case of geostationary orbit, we should take care to change the course, control the trajectory so that the probability of hitting doesn't occur. So, but to track and have this information, that itself needs a lot of expertise and also facilities. So the liabilities for damage for private companies is very important, and this damage beyond some level, it is not possible for the companies to. It is only government which has to take care of that. If the government wants to have a space industry in the country, it has to worry about the industries and create systems by which, their risks can be mitigated. They create laws, they create insurance systems, they create obligations so that, these risks could be managed. Now, coming to India, what are the potentials we have? We are one of the leaders in imaging from space. Of course, we were the leader, but we lost the first position. Now, American satellites can provide imageries even up to 40.4 meter dimension. This picture is about 0.8 meter. So, even better pictures can be given by the American satellites. And we have potentials for exporting satellites. The two best state-of-art satellites we exported to Europe. Of course, this we did in collaboration with STM. It is not easy for any satellite manufacturers to just get into international market. You need to create a heritage. Unless you have supplied 5 satellites earlier, you are not eligible to even bid a tender in an inquiry. So, to begin with, you lose the race because you are not eligible. So the only way you can overcome is to create a good partner and then get into the market and become independent. So with one of the leaders, the STM, the Indian Space Research Organization, created this kind of relation to respond to the bids and then win the bids and then supply the spacecraft. And particularly the second one, the HILAS, I should say, it is an innovation. Why? It is a broadband satellite providing broadband services to 8 countries in Europe, and all this is done in a very small spacecraft of 2-ton class. Normally this is done with a bigger spacecraft because we don't have a good launch vehicle capability, bigger launch vehicle. We were forced to innovate. We wanted to do a smaller satellite but better capability. This is how innovations are always, happen in space, because there are difficulties, because there are constraints. You try to think them and then, create solutions, try out solutions, and then prove those solutions and become the first. That is how the innovation process happens in many of these endeavors. So the organization should allow for this. The organization says, the accountant says that you have to succeed if there is a failure. You have to pay from salary. Nobody will innovate. No development will come. This is again the launch, done 10 satellites at a time. Again, a lot of innovations have come out. How these satellites can be launched in sequence. Just 1 second or a fraction of a second difference, the satellites are released, and they should not hit each other. These things very carefully it has to be done, and you have no control. It is all the distances are several thousands of kilometers. The range is away, and you should be able to do that. So it is a very extremely tricky operation. So with these things, what are the kind of future opportunities? Even looking at globally, there are burgeoning demands because of the challenges of society. There are issues of challenges of the environment, and we need resources, we exploit resources, so we need information about oil, minerals, and so on. And we need to use other resources very carefully because they are very vital for the livelihoods of people, like water and even land. The land is shrinking for agriculture. How to use the land more efficiently, sustainable way. These are the type of problems that are there, and space can provide information in conjunction with other knowledge that is generated on ground. So there is an enormous demand for this type of information, enormous demand, and especially when a country like India is growing at an economic growth rate of 8% or 9%. It becomes extremely important to have correct information to sustain the growth and have a very efficient production system, very efficient monitoring system, and so on. One great change that has happened is in the early decades of space activities, space satellites could provide services only to the institutions. The communication satellites provided their services to big companies. But today, the satellites are able to, thanks to the technology and also the convergence that is happening, satellites are able to address individually. It can send signals directly to your mobile phone. You just think of the implication of this. How market multiplies, market opportunity multiplies. Now 800 million mobile phones are supposed to be there in India. Even if 1 rupee you earn per day on each mobile, it is 800 million rupees. And per year, 360 times that. So that is the kind of potential it creates. And that opportunity has to be exploited through development of appropriate technologies. Excuse me. And of course, finally, I should say that the future belongs to those who can integrate these space activities today. They have to integrate into other areas. The positioning capability has to be integrated into mapping capability. The positioning and mapping capability should be integrated into the mobile capability. Then only you have a multiplication of the market, and it is through this process, you can generate a bigger business and bigger profit and bigger economy. So it is possible to do that with this space. And of course, at the same time, other people will not be sleeping even while you innovate. They will also be innovating. So it is necessary for you to look at how you can reduce the cost to the barest minimum. In India, they call it frugal innovations. There are many innovations. Every activity, company used to do it itself. Now somebody will laugh if company does every activity. They say that whoever provides part of the activity at the lowest cost, outsource. That is the key today for the survivability and making profit. So this type of innovation has to come and costs have to reduce. Then only we can service not only our country, but we should also look at the markets elsewhere. If Malaysia can provide satellite services to India, why can't India provide services to Thailand or Malaysia? So this is how we have to think and create systems. Of course, to create these systems, you may ask, why it is not happening. It did not happen because the government did all the business by itself. When government does everything by itself, including the business, then there is no incentive for the government to work very efficiently and compete with all the players and position itself. There are a lot of constraints because government is a very large system, large bureaucracy. So we need to create a different kind of system, different policies. So this is a very important lesson that India has to learn. We have to create policies. You allow private parties to invest and undertake activities. You have a good regulation, but make them responsible. If they fail, well, they lose their investment. So that will make them work hard, compete and grow. And many companies in India has shown that they can not only prosper in Indian market but also in global market. And I think the same spirit we have to manifest in case of activities, high technology activities like space, especially because India has achieved a lot in the field of space over the past 4 decades or so through ISRO's many programs. Thank you very much.
Ladies and gentlemen, it really wonders to know the commerce that is involved in this space technology. What a beautiful information he gave. Really the role of India in comparison with the other countries in the world. Now the commerce that is involved in this is unimaginable. Thank you very much, sir, for having given such a beautiful information, a very, very knowledgeable information, and being a scientist there in IAS, there was so much to get this data. On behalf of the Bangalore Science Forum and on behalf of all of us here, I thank you very much, sir. Friends, tomorrow we have a talk by Professor K. Siddhappa, former Vice Chancellor, Bangalore University. He is going to speak on epoch-making events in physics. And on 4th we have a talk by Professor Vishal Rao, Professor of Mathematics, Consultant Department of Electronics Engineering, Indian Institute of Science. He is going to speak on the Ramanujan's mathematics, simple illustration. On 5th, we have a talk by Dr. P. Balram, the Director of Indian Institute of Science. He is going to speak on chemical diversity in biology. I hope you have received this program sheet from this door, and if you don't have one, you can collect a copy of this, and you are most welcome to all these programs. I think he has some questions, 1 or 2 questions. Anybody? Yes, sir. Please.
Yeah, as I told, the pictures from space, of course, cover large areas, but they can give detail up to certain level. So, particularly, you cannot see the people unless it is a large group of people on ground from that height. But space provides a indirect information. I know the Home Department gets the imageries, buys the imageries, but what exactly they do with that, I don't know. So I believe that they may be using, of course, subject to certain limitations. You cannot really see individual people using the space imageries as that.
Stationary off. It's out of their life. Is that to scavenge those unwanted things and more space for newer countries?
Yeah, there are two aspects. One is at the end of the life, there is a guideline, international guideline. It is not an obligation or rule now, but the United Nations, with the consultation of all countries, have evolved these guidelines, debris guidelines. So these guidelines say that at the end of the life, you have to boost it into a higher orbit by 230 kilometers or so. So some fuel, maybe you sacrifice 3 months of a life of the satellite and boost it to a different orbit so that it presents less danger. But the latest, today, a working group, international working group is working on development of what is called space tugs. They are another type of spacecraft. They will go and attach and pull down the debris satellites. This concept very seriously international groups are working. But the feasibility of this is yet to be seen. It is in the very beginning stages, so we hope that someday people will bring in some technology of scavenging also. As of today, scavenging is out of question.
Okay.
The space program is well supported by government, but the commercial program, if they have to prosper using the space technologies developed, The government policies have to tune themselves. I think this, we are a bit slow as a country. We have not developed policies and encouraged private sector to get into more, more serious activities like, making a total launch vehicle or making total satellites and selling them in international market and so on. Government has to give certain incentives for these people. Even the ownership of satellites, we had discussed with many industrialists, like, we see Reliance we discussed, Tata's we discussed. They are prepared to put money, but they feel that at least like it was given for IT industry, for first 5 years, there should be tax holiday. So that will give them incentive to invest something like 400 crores. Or 500 crores. It's a huge investment. So today they are happy doing only service because all the DTH operators, they can get more money easily with the service than getting into risky investment in infrastructure. So government has to take some initiative.
1 minute.
Radiations anyway is cut off. We are all living on Earth because, Earth's magnetic field cuts off all harmful radiations. As far as the satellites are concerned, they are exposed to radiations. In fact, we have to protect satellites from radiation, and we design the systems in such a way that they can withstand the radiations. Still, there are degradation. The solar panels, they degrade every year by 2% or so. We lose power generating capability from solar panels because of the radiations. There are protons and also cosmic rays, and all these radiations affect the systems in space.
I am not a science student, but basically I have two questions. One is, in one of the slides you have shown Japan has more launching loads but less derbys compared to India. Why is it like that?
Japan has
launched more payload but less derbys compared to India.
Japanese have a bigger rocket. That's why. Okay. Japanese are very careful in, they passivate the systems at the end of the mission, end of the activity. They don't leave the fuel. If you leave fuel and oxidizer, some event occurs, then, if they join together, you have explosion. So what they do is they vent it out. They take away all the oxidizers and they passivate the system so that, it cannot explode. They take many such measures because of that. We started taking such measures late. All our contribution is due to one of the PSLV final stages. After sending the satellite, it was orbiting, and due to some reason, again, this fuel and oxidizer coming together, it exploded. That's why, we have a larger number.
I have one more second question. I'm sorry, there are so many people are waiting. One of the images you have shown is lower level orbits have circled the entire Earth. In that case, how do we launch the satellite launches? Won't they hit these things?
The debris, we coordinate
debris. I'm not talking about that one. Entire Earth is circled by lower level satellites. In that case, how do we launch GEO level satellites? Or don't they hit? One level of layer is occupied around the Earth by lower level satellites.
Yeah.
So in that case, how do we launch?
That is like traffic management. When you are driving a vehicle, opposite some vehicle is coming, you avoid that and go in a path, which is free for you. A similar thing is done in space also. We monitor the objects that are there, and then it is not, that picture is not to the scale. So don't imagine, there is no space at all for the rockets to go up.
Good evening, sir. I'm Prakriti. I'm a commerce student in this college itself. And my question is, as President Sir said, you are a mechanical engineer. And then MBA from IIM Ahmedabad. Is an MBA required to get into ISRO? Is it important? What is the use doing an MBA after though you are an engineer? Why again commerce?
Okay, today there is a lot of connection between the different fields. Okay, as you go up in an organization, you learn many things other than your basic, background. So if you are an engineer, you have to learn something about, law. You have to learn something about, the policy. You have to learn something about the application, particularly if it has a social application. So we always integrate the knowledge from different fields. And particularly in a high technology system, you want to use it for a business purpose. You need both knowledge of engineering and knowledge of business. Both will help you. So it is to your advantage if you have more number of. It depends on your taste. All people cannot become research scientists. It is only 5%. What we observed, even in ISRO. Most of the people, engineers who join, hardly 5% they get into research type of activities. And even if you give them administrative job, they don't like it. So such people, they focus on research and they go deeper into their field. So those are only 5%. What about 95% of the people? So they acquire skills to handle other type of jobs which are equally important. They manage people and they negotiate. They try to find out what is the actual need from the users. You design a system, if it is not useful to the user, then all the effort is a waste. So you need a certain set of people who have skills to assess and find out what is needed and then give feedback to the researchers saying that, this is what is needed. So this type of, an organization, it is a collective effort. You need different type of skills. And again, depending on your aptitude, you can always have combination. In IT industry, they prefer many people with engineering background in basic disciplines. They want aeronautics engineers, they want engineers, mechanical engineers, and so on. Because their clients belong to the industries which are in different fields. They give service to chemical industries, they give service to banks, they give service to, engineering industries and so on. So they need people of different character.
Sir, article in Yahoo, private companies are they're planning to mine asteroids for minerals, and they're planning within 5 years. Is that a possible for?
There are plans. People are studying that because some of the rare earth minerals and so on, they are found in the asteroids. So this is one of the areas of exploration. But whether it is possible in 5 years or not, I don't know. It may take much more. It is complicated, quite complicated mission. So it will take more time, in my own personal opinion. But it is going to be one of the areas of exploration for people.